Hello there, and welcome back to Science for Sleep, the place where questions about the universe drift slowly into the quiet of the night, and maybe so do you. Wherever you are right now, curled up in bed, lying on the couch, or maybe letting this play softly in the background while you stare at the ceiling, thank you for being here. Before we dive in, let me ask you something simple. What time is it where you are? Midnight? 2 in the morning? Maybe the sun hasn't even thought about rising yet. Or maybe you're on the other side of the world, where the day is just beginning and you're letting this play because you like the calm. If you find this soothing, you can always subscribe, but there's no rush. Nothing here is urgent. You don't even have to look at the screen if you don't want to. You can just listen and let the words settle around you like quiet air. Tonight, I want to talk about something that sounds familiar, but maybe isn't. You've probably heard that the universe is expanding. We've been told this so often that it feels almost unshakable, like a piece of common knowledge everyone carries around, whether or not they've ever looked into it themselves. But what if there's another way to think about it? What if the universe isn't just expanding? What if it's evolving? Now, I don't mean evolving in the way living creatures do, not exactly. But let's take a step back and ask the question in a slower, gentler way. When you look at the night sky, if you've ever had the chance to really see it far away from city lights, you know there's a sense that something is happening out there. Galaxies swirling, stars forming, black holes bending the fabric of reality itself. It's motion, yes, but not just motion. Things change. The cosmos doesn't look the same today as it did 1 billion years ago, and it won't look the same 1 billion years from now. Expansion explains the size, but does it explain the change in its nature? Or is there something else quietly at work? Maybe this sounds like a small distinction, but it's the kind of question that opens the door to something much bigger. Imagine, for a moment, the difference between a balloon inflating and a tree growing. One simply gets larger, its shape stretching, but fundamentally it's still the same balloon. The other, though, the tree, doesn't just get bigger. It changes form, complexity, and even purpose as it grows. So which one is the universe more like? Scientists have been debating this from different angles for decades, though not always in those exact words. We know about cosmic expansion. We've measured it. We've mapped it. But some ideas hint at something deeper than mere size. Some theories suggest that even the laws of physics might not be fixed. Imagine that for a second. The rules of reality themselves, slowly shifting over unthinkable stretches of time. It's not the kind of thing you'll see in a headline or hear in a quick explanation of the Big Bang. It's quieter than that. Subtle. But if true, it changes the way we see everything. Before we get ahead of ourselves, though, I want to take you back to a very simple starting point. The night sky itself. Right now, somewhere above you, whether you can see it or not, there's a universe full of galaxies. Not hundreds, not thousands, billions, each one with its own stars, planets, and histories playing out across distances so large they almost don't feel real. If you could see them all at once, it wouldn't look like static dots on a canvas. It would look alive with movement, stars forming in clouds of gas, others collapsing, vanishing into black holes, entire galaxies colliding and merging in a slow-motion dance that takes hundreds of millions of years. This is what I mean when I say evolving. The universe is not still. It doesn't simply exist, it unfolds. And if you follow that idea far enough, it starts to raise questions that are as much about us as they are about the cosmos. Because if the universe isn't just expanding, if it's actually developing, layer by layer, then where exactly do we fit into that process? Are we bystanders watching from one small corner of a vast stage, or are we part of the very thing that's growing? These questions don't need quick answers. In fact, they're better if they don't have them, at least not yet. For now, it's enough to stay with the idea and let it stretch out, like looking at a distant galaxy through a telescope and knowing you're seeing it not as it is, but as it was millions of years ago. The light is still travelling, still arriving, and maybe the idea of an evolving universe is a little like that light. It hasn't fully reached us yet, so tonight, let's start there. No rush, no need to solve it all at once. We'll look at how the universe has been understood, what expansion really means, and why it might not be the whole story. We'll talk about time, not just as a clock, but as a participant. We'll look at the way galaxies grow and change, at the hidden patterns that might be guiding them, and at what all of this could mean for this strange little moment we're living in right now, on this one small planet, listening together in the dark. Because if the universe is evolving, then in a way, so are we. And maybe the most relaxing thing of all is that we don't have to do anything but pay attention to it. Now, before we move on, take a breath. Notice how quiet it is right now, except for this voice and maybe a few small sounds around you. That quiet, that's where this begins, and it's where we're going to stay for a while, so let's follow it. You might have noticed that for all the noise we make here on Earth, the universe itself is quiet. Not empty, quiet. If you could step beyond our atmosphere and drift far enough away from every human voice, every machine, every radio signal, you would hear nothing. No hum, no wind, just silence so complete it's almost impossible to imagine. And yet that silence is not dead. It's not lifeless or blank. It has shape. Astronomers sometimes describe the universe in terms of what they can see: stars, galaxies, clusters, and great walls of matter stretching for billions of light years. But between those things, there is vast emptiness, and that emptiness is part of the structure too. If you could step back far enough, farther than our minds are built to go, you would see a pattern, a kind of invisible web where matter gathers into bright knots, leaving the spaces between them seemingly hollow. And in those hollow places, silence lives. It isn't the kind of silence that waits to be broken. It's not the pause before music starts. It's an enduring, steady quiet that has been there since the earliest moments of time itself, when the universe cooled just enough for the first atoms to form and light finally had room to travel freely. That silence has stretched ever since, growing as space itself has grown. If you could listen to it, it wouldn't sound empty. It would sound deep. It would sound like distance made real, like the space between stars has a weight of its own. Some scientists have even suggested that the universe has a faint hum, a relic of the Big Bang, stretched and softened until it's no longer something you could ever truly hear, but something that is always there, like the ghost of a sound that's been slowed beyond recognition. And here's where the thought begins to shift, because when you imagine that silence not just as an absence of noise, but as something that shapes how the universe behaves, it stops feeling passive. That stillness is not nothing. It's the stage on which everything else moves. Galaxies form their spirals against it. Stars are born into it. Even the light from the beginning of time travels through it, as if it were the quiet riverbed guiding an endless current. The silence doesn't push, and it doesn't resist. It allows. And in that allowance, everything we know happens. Think for a moment about how strange that is. We're used to thinking of the universe in terms of what it does, the explosions of supernova, the violent pull of black holes, the spinning of planets. But all of those things happen inside this larger, unshakable quiet. And it might be that this quiet has been doing something subtle all along, shaping how the universe unfolds, not with force, but by the absence of it. This is part of why some physicists look at the cosmos and wonder if expansion alone can explain it. Expansion gives us scale, but silence gives us context. Without that deep stillness, the kind that stretches between the filaments of the cosmic web, you wouldn't have a place for anything to gather or change. And if the universe is evolving, that silence might be one of the reasons it can. When we look out at galaxies billions of light years away, we're not just seeing what they are, we're seeing what they were. Their light left them long before Earth even formed. But the silence between here and there, the vast stretches of space the light has crossed, has remained untouched. It has held that light, carried it without interference, and delivered it to us as patiently as anything in nature could. That's not nothing. That's structure. That's the shape of silence itself. And if you stay with that idea for a moment, it starts to feel almost familiar. Because here on Earth, there are places where silence does the same thing. Think about a library late at night, or a forest blanketed in snow. The quiet doesn't erase what's there, it reveals it. It gives every sound, every small movement a kind of clarity. The universe might not be so different. What's fascinating is that scientists have found that this quiet isn't uniform. Even silence has texture. The cosmic microwave background, the faint radiation left over from the Big Bang, isn't perfectly smooth. It has tiny variations, little ripples in temperature that are the fingerprints of the universe's earliest moments. Those ripples eventually became the galaxies and clusters we see today. In other words, silence wasn't empty even at the beginning. It was full of potential, full of the seeds of structure that would grow for billions of years. This is where the idea of evolution, rather than just expansion, starts to take shape. Because if the universe were only stretching outward, endlessly and evenly, it would be like paint spilling across a flat surface. It would thin out, smooth out, and become simpler over time. But that's not what we see. Instead, we see complexity. We see structure becoming richer, not poorer. We see galaxies forming stars, stars forming planets, planets forming chemistry, and chemistry eventually looking back at the universe and wondering how any of it began. And in between all of those things is that same steady quiet. It has been there since the first atoms cooled, and it will still be there when the last stars fade. And maybe, in a strange way, it's what allows everything else to keep happening. If you let your mind drift with that thought for a moment, it starts to change how you see the night sky. You stop looking only at the bright points of light and start thinking about the space between them. Every star you see is surrounded by it. Every galaxy is suspended in it. And if you could somehow step outside all of it and look back, the silence wouldn't seem empty at all. It would seem like the canvas on which reality itself is being painted. Constantly, patiently, without any need for hurry. This is where we begin to see the universe not as a static thing, but as something in motion, not only outward but inward, in its very nature. And if silence has a shape, then it might also have a role in whatever the universe is becoming. When people talk about the universe expanding, it sounds straightforward. Space itself stretches, and everything in it drifts farther apart. Galaxies that once sat closer together now glide away from one another, as if carried by an invisible current. It's an idea that seems simple enough to hold in your mind, and yet, like most things in cosmology, it becomes stranger the longer you sit with it. Because expansion isn't motion in the ordinary sense. Galaxies aren't flying through space like stones thrown from a sling. Instead, space itself is what's changing. The very fabric between every star, every atom, every particle is increasing, not because of anything pushing outward, but because that's simply what the universe does. And yet, if you stop there, if you accept that single explanation, you miss something. Expansion can tell us why distant galaxies appear to be receding, why their light is redshifted as though stretched by space itself. But does it tell us why there's a structure to it all? Does it tell us why the universe didn't just smooth itself into a thin, cold haze? If everything simply moved apart forever, evenly and without interruption, what would stop it from losing every pattern it once had? Instead, we see something else. We see the cosmic web, strands of matter linking clusters of galaxies across unimaginable distances, like threads in a vast and ancient tapestry. These aren't random. They're the result of gravity gathering matter into shapes while space continues to expand around them. It's almost as if two things are happening at once. The universe grows larger, but it also organizes itself. This is where the question begins to shift. If expansion alone doesn't explain the richness of what we see, maybe the universe is doing something more than just getting bigger. Maybe it's developing. Consider what happens on smaller scales. When a star forms, It doesn't just collect matter until it reaches a certain size. It ignites. It begins to fuse hydrogen into helium, and in that process, it changes. The same thing is true of galaxies. They collide and merge, triggering bursts of star formation and reshaping their spiral arms into something entirely new. If we step back even farther, it becomes harder to imagine that the universe as a whole isn't participating in some deeper transformation of its own. One of the reasons this thought keeps coming up among scientists is that the early universe didn't look anything like it does now. At first, it was nearly uniform, hot, dense, and almost featureless, apart from tiny fluctuations in density. But over billions of years, those fluctuations grew. Matter clumped together, stars were born, galaxies spun into form, and eventually planets emerged around some of those stars. Expansion didn't erase complexity, it created the conditions for it. And if that process has been running from the very beginning, why should we think it's finished? The term evolution feels risky in this context because it's easy to imagine something deliberate when you hear it, as if the universe has intentions. It doesn't. But change doesn't require intention. It only requires time and the right conditions. And time is the one thing the universe has more of than anything else. Some scientists have even begun to ask whether the fundamental laws we think of as constant might shift over that time. Imagine if gravity itself had been slightly different in the earliest moments of the cosmos, or if the strength of electromagnetism, the force that holds atoms together, has drifted by the smallest fraction of a fraction across eons. These ideas are speculative, yes, but they point to something profound. What we think of as permanent might be as much a part of this process as galaxies and stars. If that's true, then expansion is only part of the picture. It's the stage, not the whole performance. The more we learn, the more it seems that the universe is not merely moving outward into emptiness, but also deepening in complexity, like a forest growing denser as it spreads. There's a quiet beauty in that idea, because it means that what we see when we look up at the night sky is not just the debris of a single explosion that happened long ago. It's the ongoing development of something that is still unfolding right now. Even as you listen to this, stars are forming, galaxies are colliding, and matter is rearranging itself into new shapes. And all of it is happening in a universe that seems not only to be getting larger, but also richer in structure, layer by layer, moment by moment. This doesn't mean expansion is wrong. The evidence for it is overwhelming. But it may not be enough on its own. Just as a map can tell you where the mountains and rivers are, but not what the air feels like when you stand there, expansion explains the distances, not the full experience of what fills them. If you step back and look at it this way, it becomes difficult not to wonder if there's something underneath the surface of it all, a hidden logic that drives the universe toward complexity. And if such a logic exists, it would mean that we, and everything else that has ever been, are part of a single, unbroken process that stretches from the first fraction of a second after the Big Bang to this very moment and beyond. Even the silence we talked about before plays a role in this. Expansion happens within that silence, and that silence allows it to hold its shape, the same way a blank page allows words to be written. One without the other wouldn't work. It's only together that something coherent can emerge. If you think about it long enough, this realization doesn't just change how you see the universe, it changes how you see yourself in it. We are used to imagining ourselves as observers, looking out into a vast, indifferent expanse. But if the universe is evolving, if expansion is only one part of a larger process of transformation, then we aren't outside of it. We're inside it. Every atom in your body is participating in this same cosmic story. You're made of matter that once drifted in that silence, stretched out by expansion, gathered by gravity, and reshaped by stars that lived and died long before the Earth existed. And this is why the idea of evolution, not just expansion, is so compelling. Because it means there is no clean separation between what is out there and what is in here. It's all one unfolding event, and it has been running for nearly 14 billion years without stopping. Expansion explains the size of it. Evolution explains the becoming of it. And when you put those two ideas together, you begin to see that the universe isn't simply racing away from some distant beginning. It is also continuously building itself into something new. And if that's true, then the next question is unavoidable. What comes next? If the universe has been doing this from the very start, why would it stop now? If you've ever watched a star field long enough, you might get the sense that it's alive. Not alive in the way that a forest or an ocean is alive, but alive in its rhythm. The universe doesn't sit still. It moves, it shifts, and it creates. This isn't just about expansion or motion. It's about the constant emergence of new forms, the steady transformation of matter and energy into patterns that have never existed before. That's what some physicists have begun to call the pulse of creation, though they usually choose less poetic words for it. You can see this pulse everywhere if you look closely enough. It's in the birth of stars, when clouds of gas collapse under gravity and ignite with nuclear fire, becoming brilliant furnaces that will burn for billions of years. It's in the quiet growth of galaxies, as they gather new material and pull smaller neighbours into their spirals. Even here on Earth, every living thing is a tiny echo of that same rhythm. Because all of it, every star, every planet, every cell, was built from the same raw materials forged in those ancient fires. What makes this pulse remarkable is that it doesn't appear to be slowing down. Yes, stars die. Yes, galaxies age. But new stars keep forming, and new galaxies keep colliding, reshaping themselves into entirely new arrangements. Even the universe itself seems to be accelerating in its expansion, driven by the mysterious force we call dark energy. This means that, in some sense, creation isn't winding down. It's still happening, even as the stage grows ever larger. And yet this is where things become more subtle. Because the pulse of creation isn't loud. It doesn't crash like waves against a shore. It's almost hidden in its scale. When a star forms, the process can take millions of years. When galaxies collide, the dance unfolds over hundreds of millions more. From our perspective, these things look still, as if nothing is happening at all. But if you could speed up time and watch it like a film, you would see a universe that is constantly rearranging itself, layer upon layer, moment after moment, without pause. This raises a question that's both unsettling and strangely comforting. Is this pulse something the universe has always had? Or is it something that has been developing along the way? If we look back to the earliest moments after the Big Bang, the universe wasn't creating stars or galaxies. It was hot, uniform, almost featureless except for the faintest fluctuations in density. But those fluctuations were enough. They were the seeds, and from those seeds, the pulse began. It's almost as if creation itself emerged gradually, like music starting as a single note before building into a symphony. First, there was simple hydrogen, then helium. Then the first stars lit up and forged heavier elements in their cores. Those elements were scattered when those stars died, and from their ashes came new stars, new planets, and eventually, in at least one small corner of the universe, life. Each step added complexity, and each step built upon the last, as if the universe had been learning how to create by simply existing. And this is where the idea of an evolving universe begins to feel not only possible, but almost unavoidable. Because if creation has a pulse, it isn't the same now as it was in the beginning. It has grown richer, more varied, and perhaps even faster in certain ways. Think of the early universe as a kind of cosmic childhood, simple, unformed, full of potential, but lacking the intricate patterns we see today. What we live in now might be closer to its adolescence, a stage where it has already formed countless stars, galaxies, and planets, but continues to create new ones as if it's still far from finished. Even the laws of physics, as steady as they seem, could be part of this pulse. There are theories that suggest that what we call constants, those numbers that define how strong gravity is or how fast light travels, might not be perfectly fixed. If they have shifted even slightly over billions of years, then the universe hasn't just been creating new things. It's been creating itself in an ever-changing way, the rules slowly rewriting themselves as the story unfolds. For us, though, this pulse is almost invisible. We live our entire lives within a tiny window of cosmic time. A star like the Sun will burn for roughly 10 billion years, and we get perhaps 80 or 90. To us, it feels as if the universe is frozen. But if you could look at it the way a galaxy might, stretched across aeons, you would see constant movement, a deep, steady rhythm that never stops. And this brings us back to a question that has been quietly sitting under all of this. If the universe has a pulse, where is it leading? Is it moving toward something? Or is this endless act of creation simply what it is, with no destination other than itself? We don't have an answer to that, and maybe we never will. But there's something strangely grounding in the fact that we're here in the middle of it, listening to it happen in real time, even if we can't hear it directly. When you look at the stars tonight, what you're really seeing is the residue of that pulse, light that left its source millions or billions of years ago, carrying with it the evidence that creation hasn't stopped. And this is why, when scientists map the sky, when they trace the filaments of galaxies and measure the faint glow of the cosmic microwave background, they're not just collecting data, they're listening. They're searching for the rhythm, trying to understand how the universe beats and whether that beat has changed over time. The more we study it, the clearer it becomes that expansion alone is too simple. The universe doesn't just grow, it builds. It reorganizes itself into ever more intricate forms. And if there's a pulse behind all of it, then maybe what we've been calling expansion is only the backdrop, the slow rising tide against which this ongoing creation continues. And it is against that tide that we will keep looking, because if the universe is evolving, not merely stretching but deepening, then the next step isn't to watch it from afar, it's to ask what that means for the future, for the next movements in this long, unending rhythm that has been playing since the beginning of time, because the pulse is still there, and it hasn't missed a single beat. When we talk about time, we usually picture it as a line, a straight path that begins in the past, stretches through the present, and continues into the future. But in the universe, time doesn't behave like a simple line. It flows, it bends, it stretches, and it sometimes slows down depending on where you are and how you move. It's not static, and it's not separate from space. Together, space and time form the fabric of reality itself, and that fabric has a kind of motion to it, one that carries everything in existence forward whether we're ready for it or not. The river analogy is often used for time because it captures this movement in a way that feels almost tangible. A river can rush, or it can meander. It can split into branches or crash over falls, and if you're inside it, you don't get to step out and watch it from the bank. You can only feel it as it carries you along. That's what time is like for us. We don't stand outside it. We live inside its current, every second pulling us from one moment to the next. Einstein's theory of relativity sharpened this picture in ways that still feel unsettling. Time is not the same everywhere. It moves differently for someone standing still and for someone racing close to the speed of light. Gravity bends it, stretches it, and even slows it down near massive objects. If you could hover just above the surface of a black hole, a few minutes for you could mean thousands of years passing for someone far away. In a universe that evolves, this isn't just an odd feature of physics. It's a sign that time itself is woven into the same transformation. When you look at the stars, you're not seeing them as they are. You're seeing them as they were. The nearest star beyond our sun is over 4 light years away, which means its light has taken more than 4 years to reach you. Many of the stars you see are hundreds or thousands of light years away. Some of them may not even exist anymore, their light still travelling toward us across the vastness of space like messages from the past. This means that every night sky is a kind of layered memory, and in that memory you can almost see how the universe has been flowing, just like that river. But what if this river isn't just carrying everything forward? What if it's shaping things as it moves? Imagine the earliest universe, hot, dense, and almost featureless. Over time, as the river flowed, it allowed matter to cool, to clump, to form stars and galaxies. It wasn't just that things happened in time. Time itself was a condition for things to happen at all. Without the river, there would be no direction for the universe to evolve. This raises a deeper question. Does time itself change as the universe expands? Some cosmologists think it might. In the earliest moments after the Big Bang, the universe was so small, so dense, and so fast-moving that time may have flowed differently, almost unrecognisably from the way we experience it now. As space stretched, the river slowed, and as it continues to stretch, maybe the flow of time will keep changing in ways we're only beginning to imagine. If this is true, then what we call the present is not a universal moment shared across all of existence. It's local. Every galaxy, every star, every planet has its own rhythm, its own tiny slice of the river's current, and yet somehow, despite this, the universe evolves together. Like countless tributaries joining the same ocean, every point in space and time participates in one grand movement, even if each one flows at its own speed. This is why thinking of time only as a straight line can be misleading. A line suggests separation, one point after another clean and distinct. But a river is continuous. You can't point to one droplet and call it the river. The whole river is the movement itself, and so is time. Every moment you experience is tied to every other, stretched across the vastness of the cosmos like an unbroken current. And here's where it becomes even stranger. If time is a river, then the past isn't gone in the way we usually imagine. Those ancient moments, the birth of the first stars, the collisions of the first galaxies, they still exist in some sense, written into the structure of the universe itself. We see them every time we look farther into space. A telescope is like a boat that can travel upstream, letting us glimpse earlier stretches of the river. The light from the beginning is still out there, still moving toward us, still carrying the story of what once was. This is why astronomers build bigger and bigger telescopes. They're not only trying to see farther out, they're trying to see farther back. Each step deeper into the cosmos is a step upstream, closer to the source, closer to the earliest ripples in the river of time. And the farther they look, the more they begin to wonder whether this river has hidden depths we haven't reached yet. Places where the flow is so different that even our best theories might fail to describe it. If the universe is evolving, then time is not simply a backdrop. It's a participant. It's part of the same transformation. The expansion of space, the formation of galaxies, even the birth and death of stars, all of these things unfold not only in time but with time, as though time itself is learning to hold more complexity, to carve out new channels in its own flow. We may never feel this directly. To us, time is just the steady ticking of a clock, but that's only because we live in one small corner of the river, moving at one particular speed. If we could step back and see it all at once, the early universe, the present, and the distant future, we might discover that the river isn't just flowing forward. It may be branching, curling, and looping in ways that we can't yet imagine. And if that's the case, then the evolution of the universe isn't only about space expanding or matter forming. It's also about time itself, about the way the river has been reshaping its own course since the beginning, which means that what we think of as now is only one brief eddy in a far larger stream. If you look up at the night sky, you might see a handful of stars if you're standing in a city, or thousands if you're somewhere dark enough. But what you're really seeing are only fragments of a much larger story. Every single star belongs to a galaxy, and each of those galaxies carries not just light, but history. They are more than clusters of matter. They are records, written in the language of gravity and time, tracing how the universe has unfolded since its earliest moments. When astronomers point their telescopes deep into the sky, They're not only looking at distance, they're looking at time itself. A galaxy 1 billion light-years away isn't just far. It's old. Its light left long before humans existed, before Earth had continents the way we know them now, and only now has it reached us. That galaxy may have changed, merged with others, or even ceased to exist in the way we see it, but its light is still telling its story. Each galaxy is like a chapter in the universe's memory, and the farther we look, the earlier the chapter. Some are sprawling and elegant spirals, with arms sweeping outward like a slow-turning wheel. Others are ellipticals, round and filled with ancient stars that long ago burned through their brightest fuel. Some are irregular, twisted by collisions and reshaped by gravity's pull, scars from encounters written across their structure. What's remarkable is that all of them, no matter how different, share the same quiet function. They hold on to time. A galaxy is a map of everything that has happened within it. The birth of stars, their deaths in brilliant supernovae, the clouds of gas reshaped by those explosions, and the slow gathering of new stars from the remains. It's a cycle that repeats, and in that repetition, a galaxy keeps the memory of how the universe has been changing. When you trace that story far enough back, you reach a time when galaxies didn't even exist. The early universe was too hot, too uniform, too simple for such structures to form, but gravity, patient and tireless, gathered matter together until the first galaxies emerged. And from those first gatherings came everything else: the building of heavier elements, the birth of planets, and eventually the conditions that would make life possible. You don't see that history in a single glance. You see it in the details, in the colour of a galaxy's stars, in the way its spiral arms curve, in the faint glow of gas stretching between its edges. Even its shape is a record. A perfectly symmetrical spiral suggests calm, steady growth. A lopsided one hints at collisions, at two galaxies passing through each other in slow-motion encounters that last hundreds of millions of years. Nothing in a galaxy is random. Everything is an echo of what came before, and here's where time becomes less of a line and more of a web. Each galaxy doesn't just carry its own story. It shares that story with countless others. When galaxies collide, they don't simply erase their past. They combine it. Their stars keep orbiting, their gas clouds keep swirling, and over ages they merge into something new. Two separate histories become one. The river of time for each galaxy meets and flows together. The Milky Way, the galaxy we live in, is no different. It has swallowed smaller galaxies before, and it will again. In a few billion years, it will merge with the Andromeda Galaxy, creating a single, larger galaxy with a new shape and a new identity, but still carrying every moment that came before. Not one star will forget where it came from. They'll just keep moving, pulled into new paths, part of a larger and quieter story written in orbits and light. When you realize this, a strange thought follows. If galaxies are stories, then time is the ink that writes them, but not in the way you might expect. Time doesn't rush through galaxies. It lingers there. Every star that was born billions of years ago and still burns today is a line of text that hasn't faded. Every dead star that left behind a cloud of gas or a black hole is another word in that ongoing sentence. Nothing is ever erased, it simply becomes part of the next line. And if you step back far enough, you begin to see the universe itself not as a single flowing moment, but as a vast library. Every galaxy is a book. Every star is a page. The light we see from them is not just illumination. It's a record of what time has done. And the deeper you look, the older the shelves become, filled with volumes from an era so early and strange that even the concept of time was different. But what happens if you keep going, if you go past the shelves of galaxies entirely, back to the moment before those stories began? That's where the river of time narrows into something almost unimaginable. The early universe wasn't divided into stars or planets, or even atoms as we know them. It was a single, hot, dense expanse, and from that state, everything we now see had to emerge. To understand what it means for the universe to exist without time, or for time to be something that only appeared later, we have to step into that beginning. Because before there were galaxies, before there were stars, before there was anything that could change in a way we'd recognize, it's possible there was no time at all, only a state of being that hadn't yet started to flow. And if that's true, then what we call time might just be a story that began later, one that galaxies now hold in their light, their shapes, and their endless slow motion. To follow it, we have to go deeper, to the point where time itself might have first started to move. When we think of memory, we usually imagine it as something personal, a recollection in the mind, a moment tucked away in the brain's folds. But the universe has its own kind of memory, one that doesn't depend on thought or awareness. It's written into the very structure of existence. Every galaxy, every star, every particle carries a trace of where it has been and what it has experienced. It isn't memory in the human sense, but it's memory all the same. You can see it most clearly in the light that travels across space. A photon born in the heart of a star carries with it a record of its origin. It crosses trillions of kilometers without aging in the way we think of aging. When it finally reaches your eyes or a telescope's mirror, it brings with it not just brightness, but history. That light has been in flight for millions, sometimes billions of years. In a way, every glimpse of the night sky is an act of remembering. You're not just seeing where those stars are, you're seeing where they were, and it doesn't stop with light. Space itself remembers. When a massive object moves through space-time, it doesn't pass without leaving a mark. Gravity sends out ripples, gravitational waves, that travel outward forever. They are unimaginably small by the time they reach us, stretching and compressing space by less than the width of a proton. But they are there. They are the echoes of immense events, two black holes merging, a pair of neutron stars colliding. Each wave is a kind of cosmic footprint, a reminder that something once happened in a distant, unseen part of the universe, and that its effect still exists. Even galaxies themselves hold memory. Their shapes, their motions, their scars from collisions, they are records of a past written in starlight and gravity. You could look at the Milky Way and trace its history through the streams of stars that once belonged to smaller galaxies it absorbed. Those streams are still there, like threads of memory woven into a larger whole. They don't fade quickly. They remain, turning slowly in the galaxy's halo, silent witnesses to an ancient past. And then there is an even deeper memory, one that stretches back farther than any star or galaxy, the cosmic microwave background. It is the oldest light we can see, the faint afterglow of the Big Bang itself. Every patch of it carries tiny variations, slight differences in temperature that trace the universe's earliest moments. Those variations became the seeds of every galaxy, every star and every planet. In those faint ripples of radiation, the universe has preserved a snapshot of its own beginning. This kind of memory is not stored in words or images. It's not something you can hold. It's woven into the fabric of reality itself. The laws of physics don't allow the universe to forget. Energy and information don't vanish. They transform. They move. They hide in different forms, but they remain. Even a black hole, the most extreme object we know, seems to resist erasing memory completely. Physicists still argue about what happens to the information that falls in, but more and more, the evidence suggests that in some way, it's still there, encoded in the horizon, written into the universe's ledger. If the universe remembers everything, then time might be less about movement and more about access. What we call the present could simply be the part of this memory that we're able to touch right now. The past isn't gone. It's simply elsewhere in this vast record, and the future is waiting, already inscribed but unread. We don't see it all at once because our minds are not built to read the whole archive in one glance. We move through it piece by piece, frame by frame, moment by moment, And this is where the illusion of time starts to dissolve into something larger. Maybe time isn't a river we drift through, but the act of turning pages in a book that has already been written from cover to cover. Galaxies, stars, even the faint background light of the cosmos are the ink on those pages, and every second we live is simply another line we're tracing with our eyes. But if all of this is true, if the universe is memory from one end to the other, then it raises an even deeper question. Who or what is doing the reading? If the universe holds every event at once, why do we only see a sliver of it? Why can't we step outside and view it whole? To answer that, we'll need to look closer at how time itself might emerge, not from some universal ticking clock, but from our place inside this endless memory, and from the way we experience change one layer at a time. If you look long enough at the universe, you start to notice that nothing is truly random. There are patterns beneath everything, quiet shapes that repeat at scales too large or too small to see at first glance. Stars gather into galaxies, galaxies cluster into vast webs, and even the faintest background radiation is mapped with subtle ripples that carry the memory of how it all began. These patterns aren't only in space, they're in time too. When scientists study the large-scale structure of the universe, they find something remarkable. Galaxies aren't scattered like grains of sand. They form filaments, long, delicate threads stretching millions of light years, separated by enormous empty voids. From far enough away, it almost looks like a neural network or the branching of roots underground. This isn't just a random arrangement. It's the frozen imprint of the early universe, the outcome of tiny fluctuations in the primordial plasma that expanded and evolved into the structure we see today. Each thread in this cosmic web is a record of motion, of matter gathering under gravity's pull over billions of years. It's as if time itself has carved these lines, sculpting the universe into something with form and order. What's extraordinary is that these same kinds of patterns repeat at different scales. The spiral arms of galaxies echo the curves of larger cosmic filaments. The distribution of stars in a galaxy reflects the same gravitational rules that shape the universe as a whole. Even deeper than this, at the quantum level, there are patterns in the way particles interact, probabilities weaving together to form the matter we touch and see. It's a strange symmetry. The same laws that govern the orbit of galaxies also guide the behavior of the smallest particles. Different scales, same underlying logic. This unity suggests that time may not be something that flows independently, but something woven into these patterns, emerging from the relationships between things rather than existing on its own. Some physicists believe that if you could peel back these layers, you might find that time itself is nothing more than the structure of these patterns playing out. It wouldn't be a thing in and of itself, but the shape created when one event is compared to another and then another until a sequence appears. In other words, what we call time may be our way of tracing the outlines of a much larger design. This could explain why, even in the deepest theories of physics, time sometimes vanishes. In certain formulations of quantum gravity, the equations don't include time as a fundamental ingredient. Instead, they describe a static web of connections, a timeless map of how pieces of the universe fit together. In that picture, time emerges only when you look at how one part of the pattern relates to another, how change is noticed from within the system rather than from outside it. The most intriguing thing is that we may already see hints of this in our everyday lives without realizing it. When you lose yourself in a moment and stop paying attention to the clock, you're not just distracted, you're slipping into a different relationship with those patterns. You're not measuring change against a schedule, you're simply inside it, and for that brief time, you stop feeling time as a separate thing at all. If this view is right, then the universe doesn't really need time. It only needs the structure of change, the underlying patterns from which time is built. These patterns have been there since the beginning, long before clocks, calendars, or even the first stars. And in a way they'll remain even if our familiar sense of time eventually fades. but there's still something missing. Patterns explain how the universe is arranged, but not why time feels like it has direction. We can trace a pattern backward as easily as forward in mathematics, but in our lives, time only moves one way. The question of why that is, the reason you remember yesterday but not tomorrow, takes us to the heart of one of the strangest and most important features of reality. And to understand it, we have to look at what time does when it slows down, and what happens when it nearly stops altogether. If you've ever watched smoke rise from a candle, you know there's no way for it to return to the wick. A glass shatters, but it never reassembles itself. You grow older, never younger. These aren't just everyday experiences, they're the evidence of something profound. The universe has a direction. Time, at least as we live it, moves one way. Physicists call this the arrow of time, but at its core it might be better understood as the arrow of change. The laws of physics, at their deepest level, are mostly reversible. If you look at the equations that describe how particles move or how gravity works, there's nothing in them that forces time to move forward. They work just as well backward. A film of colliding particles could be run in reverse and still follow the rules, and yet that's not what happens in the world we see. You never drop a cup, hear it shatter, and then watch the shards leap off the floor and rebuild themselves. Something in the universe pushes events in a single direction, and that something is entropy, the measure of disorder. Over time, disorder tends to increase, not because there's a law that says it must, but because there are far more ways for the universe to be disordered than for it to be neatly arranged. A broken glass is more probable than a perfectly reassembled one, and so the arrow points forward. This is why you remember the past but not the future. Memory is tied to this direction. Your brain, your body, even your cells operate in a world where entropy increases, and that rise creates the sequence of cause and effect you experience as time. The arrow isn't really about clocks, it's about the fact that change builds on itself. Once something happens, it leaves a trail, a record in the universe's memory that can't be undone. When you step back, this arrow is everywhere. It's in stars burning their fuel and slowly drifting toward collapse. It's in galaxies merging, never separating back into their original pieces. It's in the faint background radiation, stretched thinner and colder as the universe expands. Each of these changes only goes one way. Even though the underlying laws don't demand this direction, the combined effect of everything in the universe makes it nearly impossible for it to go any other way. This is why time feels so real to us. We live inside this arrow. Our bodies, our thoughts, and our very sense of self are tied to processes that unfold in one direction. You couldn't exist in reverse because your biology depends on energy flowing from higher to lower, on systems gradually running down. In that sense, the arrow of change isn't just a feature of the universe, it's the foundation of our experience. But here's the strange part. If you look far enough ahead, this arrow might not be permanent. Some theories suggest that in the far future, when the universe has expanded so much that stars have burned out and everything has cooled close to absolute zero, change itself could nearly stop. A frozen cosmos with no more complex motion, no more new structures forming, no more differences to track. If that happened, what would time even mean in a universe like that? This question cuts to the heart of the idea we've been chasing. Maybe time is not the thing itself. Maybe it's only the shadow of change, and when change slows down enough, time fades with it. The arrow would no longer point anywhere because there would be nothing left to move it forward. But we are nowhere near that. For now, the arrow of change still drives everything, from the growth of galaxies to the ticking of your own thoughts. And if this arrow is the key to understanding why time feels so real, then the next step is even stranger. To consider whether this arrow is unique to our universe at all, or if there might be something beyond it, a deeper reality in which this direction we call time is just one of many possible paths. And to see that possibility, we have to step back from the arrow entirely and imagine a universe where there was no first push, no starting point, just an endless existence that doesn't need a beginning or an end. Everywhere we look in the universe, there is a rhythm. Stars are born in clouds of gas, shine for millions or billions of years, and then die, scattering their remains into space. Galaxies collide and merge, reshaping themselves over unimaginable spans of time. Even the universe itself seems to have a kind of life cycle. It began with a burst of expansion, grew into the cosmic web of stars and galaxies we see today, and will keep changing long after we're gone. But if everything has a beginning and a period of growth, what comes after? We often think of time as a straight line with a clear start and a clear end. But when you study the universe closely, that picture starts to break down. Stars don't simply vanish. Their matter becomes fuel for something else. The heavy elements forged in their cores, carbon, oxygen, iron, are scattered outward, eventually becoming part of planets, part of atmospheres, even part of life. Galaxies too don't disappear when they collide. They become new galaxies, their stars blending together, their gas clouds mixing and igniting fresh waves of star formation. In this sense, the universe doesn't really deal in endings. It transforms. One stage becomes the next. What looks final is only another step in a larger sequence. And if you follow that sequence far enough, you start to wonder if there's ever truly a point where it all stops, or if stopping is simply another transition we don't yet understand. This is why some physicists and cosmologists suspect that even what we call the birth of the universe might not be the absolute beginning. The Big Bang, as extraordinary as it was, may only have been the start of this particular phase of reality, not the start of existence itself. There are theories that suggest our universe could be part of a larger cycle, one of many expansions and contractions, or perhaps one bubble among countless others in a vast cosmic sea. If that's true, then time as we know it might not stretch from a single point forward into an empty future. It might loop, it might branch, it might even be irrelevant at the deepest level, replaced by something we can't yet picture, a state where before and after are meaningless, because everything simply is. But even if we don't know what lies beyond the visible span of cosmic history, what we do see already changes how we think about time. When you look at a galaxy billions of light years away, you're seeing it as it was in its youth. When you look at the stars in our own sky, you see them in different stages of their lives, some just beginning, some long past their peak. The universe contains every phase at once, as if the entire timeline is on display together, layered across space. And that brings us to an unsettling thought. Maybe there isn't really a single now for the universe. What we call the present is just our point of view, our local place in the sequence of change. Somewhere far away, a star is just forming. Somewhere else, another is collapsing into a black hole. Farther still, light from the very first galaxies is only just reaching us. In a sense, every stage of cosmic life, birth, growth, transformation, is happening at the same time. So what happens after growth? Maybe nothing final. Maybe just another step, one we can't yet name. We might be living in the middle of a story that has no true beginning and no ultimate end, just an ongoing transformation, one state giving way to another as the river of change keeps flowing. If the vastness of the universe suggests that time is a grand sweeping current, then the quantum world tells an entirely different story. Down there, at the smallest scales, time begins to lose its familiar meaning. Instead of a steady flow, it becomes uncertain, fragmented, almost optional. And in that strange uncertainty, we may catch our first real glimpse of what the universe might be like without time at all. In quantum mechanics, particles don't behave the way objects in our everyday world do. They don't have definite positions or speeds until we measure them. Instead, they exist in clouds of probability, overlapping possibilities that only collapse into a single outcome when observed. A particle can be in many states at once, its future undecided until an interaction forces it to choose. If you think of time the way we normally do, one event following another, clean and orderly, this is almost impossible to reconcile. How can there be a before and after if, in between, reality itself doesn't commit to one path? This is why, in the equations that describe the quantum world, time isn't treated the same way it is in classical physics. In fact, many of those equations can be written without time at all. They describe relationships, how one state connects to another, without needing a universal clock to keep things in motion. This has led some physicists to wonder if time is not fundamental but emergent. In other words, maybe time only appears when we step back far enough, when countless quantum events average out into the smooth flow we experience in daily life. At the smallest scales, there may be no ticking, no rhythm, no now moving forward. There may only be a vast web of possibilities, each linked to the others, timeless until something larger, like us, looks at it from the outside and calls it time. Even stranger is the phenomenon of quantum entanglement. Two particles can become connected in such a way that no matter how far apart they are, their states remain linked. Measure one, and you instantly know the state of the other. This happens without any signal travelling between them, and it doesn't seem to care about distance. Some researchers have suggested that this kind of connection hints at a level of reality where space and time themselves are not the primary ingredients. The particles don't exchange information in time, they simply exist in a relationship that transcends it. If that's true, then maybe what we call time is a byproduct of stepping down from that deeper level. At the quantum foundation, everything could simply exist in a single timeless state, with time emerging only when we zoom out and look at it from the perspective of larger structures like planets, stars, and galaxies. And if that sounds unsettling, there's something comforting in it too. It suggests that time as we know it isn't the full story. It's just one way of experiencing a universe that may be far richer than we can perceive. Every second that passes might not really be disappearing. It might be sitting there, part of a bigger whole that the quantum world never lets go of. But if time is something that only emerges, then what does that mean for everything we've built on top of it? What happens to our idea of a beginning or an end if time itself is a secondary feature of reality? If the quantum world offers a glimpse of timelessness on the smaller scales, then the structure of the universe reveals another kind of order on the larger scales. When astronomers map the positions of galaxies across the sky, they don't find a random scattering. Instead, they see something almost alive in its complexity, an intricate network stretching across the cosmos, a vast interconnected structure known as the cosmic web. This web is made of filaments, immense strands of galaxies bound together by gravity, and between them lie enormous voids, regions of space so empty they span hundreds of millions of light years. From a distance, it almost looks like a neural network or a system of roots buried in the dark, connecting everything in ways we're only beginning to understand. This is the universe's skeleton, the framework that has guided the formation of galaxies and clusters for billions of years. What's remarkable is how these filaments came to be. They are the fossilized result of tiny fluctuations in the early universe, minute differences in density imprinted on the fabric of space shortly after the Big Bang. Over billions of years, gravity amplified those differences, drawing matter together into strands while leaving vast empty regions in between. Every galaxy you see, every cluster of stars, every luminous shape in the sky is a bead strung along one of these filaments. And in a way, this structure is a map of time. Each filament tells the story of how matter flowed and gathered, how small clumps became larger ones, how the universe slowly wove itself into this web. The galaxies sitting in these filaments aren't just locations in space. They are events in history, suspended across billions of years, each one a record of how the cosmic pattern evolved. If you could look at this web in its entirety, you wouldn't just be seeing distance. You'd be seeing time itself laid bare. Some of the galaxies on these threads are close enough that their light left them only millions of years ago. Others are so far that the light we see now departed when the universe was young. Look deep enough, and the web becomes a living timeline, every strand a path stretching backward through cosmic history. And yet, this web is not static, it is still changing. Galaxies slide along these filaments like pearls on invisible threads, pulled by gravity toward one another. Entire clusters drift toward eventual collisions, drawn by the same force that first wove the web together. Even the voids between the filaments aren't empty forever. They too are shaped by the slow migration of matter across the cosmic landscape. Some researchers believe that if you follow the web far enough, you may find that it has no clear center, no single point from which everything began. The same intricate structure repeats itself across scales, from the smallest galaxy groups to the largest superclusters, and if there is no privileged point, no single origin written into its design, then maybe the universe isn't a story with a simple beginning and end. Maybe it's more like a pattern, endlessly unfolding, its structure existing all at once in ways we can only see piece by piece. This is where the question of time becomes unavoidable again. If the web is a record of everything the universe has done, then every part of it is a frozen moment from a different era. And yet all of those moments exist together in one vast framework. The past isn't gone, it's simply far away. The future isn't here, but it's somewhere waiting along filaments we haven't reached. Seen this way, time is not the current that carries the web forward. It's the way we move through it, tracing one thread after another, connecting dots that already exist. But if the cosmic web holds every era at once, then what happens in the places where its threads cross, where gravity knots space and time so tightly that the ordinary rules no longer seem to apply? We tend to think of the laws of physics as unchanging, like an eternal script that the universe has followed from the beginning and will follow until the very end. Gravity always pulls, light always travels at the same speed. The rules that shape the stars and galaxies seem so absolute that we can hardly imagine them being otherwise. But what if those laws are not fixed? What if, instead of being eternal, they have been evolving, just like the universe itself? It's an idea that challenges one of our deepest assumptions, that the universe is governed by a single, unbreakable framework. But as we look more closely at the cosmos, we find hints that the laws we take for granted may not be quite as rigid as they seem. Some physicists have even suggested that in the very early universe, what we now call the laws of nature might have been different, perhaps simpler, only settling into their current form as the cosmos cooled and expanded. This isn't as far-fetched as it sounds. Consider how physical constants, like the strength of gravity or the charge of an electron, seem perfectly balanced to allow the universe to exist in the form we know. If these values had been slightly different, stars might never have formed, galaxies might never have taken shape, and life might never have had a chance. Why are they what they are? Some theories propose that they weren't always this way. They might have shifted over cosmic time, changing as the universe matured, the same way matter itself has evolved from a hot uniform plasma into the complex structure we see now. In this view, the laws of physics are not timeless commandments. They're more like the stable patterns that emerge from a deeper, underlying reality. Patterns that may have been fluid at first, only becoming rigid as the universe grew. In the beginning, when everything was compressed into a state where time itself barely existed, the very rules of nature may have been in flux, settling into place only as the cosmic stage expanded enough for them to take hold. If that's true, then even what we call time might be part of this process. Time could have been something that crystallized out of this evolving structure, not a fundamental backdrop, but a property that appeared once the universe became ordered enough to support it. Before that, there may have been no clocks to tick, no before or after, only a raw, timeless state where nothing needed a sequence. This idea is difficult to test, but there are faint clues. Astronomers study the light from the oldest stars and galaxies, searching for any sign that fundamental constants might have been different in the past. So far, no clear variation has been found, but even the act of looking reveals how much this question matters, because if the laws of physics are not fixed, then time itself might be tied to that evolution, a feature of the universe that can appear, shift, or even vanish if the conditions allow it. And that thought leads to an even stranger possibility. If the laws of physics evolved once, could they evolve again? Could there be regions of the cosmos where time works differently, not because of gravity or motion, but because the underlying rules are not exactly the same as the ones we know here? This is where the boundary between time and timelessness starts to blur, because if the laws of physics can change, then the thing we call now may only exist in its current form because of those laws, and if they had been different, our experience of time might have been different too. When you look up at the night sky, it's easy to imagine the universe as something ancient and unchanging, a vast and silent elder that has always been what it is. But what if that image is misleading? What if the universe is not an old and finished thing, but something that, in many ways, is still young, still learning, still growing, still unfolding into what it will eventually become? Scientists sometimes describe the early universe as if it were in its infancy. In those first fractions of a second, everything was raw and unformed. Space and time, if they existed at all, were tangled together in ways we can barely understand. The laws of physics, the ones we now treat as unshakable, may have been simpler then, or even incomplete. Over billions of years, they seem to have stabilized, settling into the rules we know today, much like a child eventually grows into their adult shape. If the universe can evolve, then time itself may be part of that growth. What we call time might not be a feature that has always been there. It could be something that only emerged after the universe reached a certain stage of development, like language emerging in a young mind. Before that, in the earliest moments, there may have been no ticking clock at all, just a kind of raw potential, a state that had not yet divided itself into past, present, and future. Even now, the universe carries signs of that youth. When astronomers look at distant galaxies, they're looking backward in time, seeing the cosmos not as it is today, but as it was billions of years ago. The galaxies in those deep images are smaller, less structured, and less mature than the ones around us. In a sense, we can watch the universe growing up. Each step in that growth marks a point where order emerged from what once was formless, and along the way, time became something that could be measured, felt, and experienced. Thinking of the universe this way changes how we see its apparent age. Yes, it's nearly 14 billion years old, but in cosmic terms, that might still be early days. Galaxies continue to form, stars are still being born, the cosmic web is still weaving itself into new patterns. The universe might not be finished, and if it's still unfolding, then our experience of time may be tied to that ongoing process, a feature of a cosmos that has not yet reached its final shape. If that's true, then time is not the master of the universe. It's one of its offspring, something that came into being as the cosmos itself matured. And if the universe is still young enough to be changing, then maybe even the way we experience time isn't permanent. It could shift again in ways we can't yet imagine, just as a child's perspective changes as they grow. This way of looking at the universe is unsettling, but it's also strangely hopeful. Because if the universe is still young, then so are we. Everything we think of as fixed, time, space, even the laws of nature themselves, might just be part of an ongoing story, one that is far from over. And that brings us to something even deeper. If the universe is still growing, then maybe it isn't simply in time. Maybe its growth is what gives time its meaning in the first place. And if the universe is still learning to be what it is, then perhaps what we experience now is only one chapter in a much larger process. One that may not need time at all when it's finally complete. If the universe is still growing, then where do we fit in? Are we simply passengers, drifting along while it expands around us? Or is it possible that we're part of the process itself? When you look at the history of the cosmos, it's easy to feel small. Galaxies form and collide, stars burn for billions of years, and entire worlds rise and fall without any sign that they were ever there. But if you step back and look at it from another angle, something remarkable happens. Life appears. Out of the same matter that formed stars and planets, tiny patterns began to emerge, patterns that learned to adapt, to change, to remember. Eventually those patterns became us. And here's the strange part. We are not separate from the universe, we're made of it. Every atom in your body was forged in the heart of a star. The calcium in your bones, the iron in your blood, the oxygen you breathe, they all came from events that took place long before you existed. You are, quite literally, the universe looking at itself. If that's true, then maybe our consciousness, our ability to think, to reflect, to wonder, isn't an accident. Maybe it's part of the way the universe continues to unfold. Stars don't think, planets don't imagine, but we do. We build telescopes to look deeper, equations to describe what we find, and stories to make sense of it. In doing so, we're not just moving through time. We might be adding to the universe's growth in a way that's different from how space expands or how galaxies drift apart. Consider this. The universe began in a simple state, a nearly uniform sea of energy and matter. Over billions of years, structure emerged. Galaxies formed, stars ignited, planets cooled. And then, on at least one of those planets, awareness appeared. That awareness is now capable of changing the universe in ways nothing else can. We reshape matter, release energy, and even send signals across space. Perhaps this is just another stage in the same process of cosmic growth that started at the beginning. If that's the case, then maybe time as we experience it isn't only a measure of change. Maybe it's a way for the universe to allow complexity to build on itself step by step. Each moment gives rise to the next. Each thought, each discovery, each small act of understanding adds to the story. We're not just inside the universe's timeline, we may be helping to write it. This doesn't mean we control the cosmos, or that the universe depends on us. But it does mean that our experience of time might be tied to something larger. We live in a universe that grows and we grow with it. In a way, our existence is proof that time, at least the kind we know, serves a purpose, even if it isn't fundamental. And yet, if we're part of the universe's growth, what happens if that growth someday reaches an end? If time had a beginning, could it also have a final stage? A point where everything that can exist already does, and change itself stops? That's the question that leads us closer to the edge of everything we know. Because if the universe is growing through us, through stars, through galaxies, then we have to ask, is there a point where it no longer needs time at all? If the universe is still growing and if we are part of its unfolding story, then who or what watches it all? Not in the way we watch a movie from the outside, but in the quiet, ever-present way that something can exist without interfering, simply observing. In a sense, the universe itself is that witness. Every event, every motion, every moment is recorded in its structure. When a star burns out, its light travels on. When you take a single breath, the molecules scatter into the air and leave their faint trace forever. Nothing is erased. It's all written into the fabric of reality, even if no one is there to see it happen. And yet, there's another witness, one closer to home, you. Every moment you experience, every memory you carry is another way the universe observes itself. You're not separate from it. Your awareness is just another feature of its endless complexity. When you look up at the sky and see the faint light of a star that's been travelling for millions of years, the universe is watching itself through your eyes. This thought has a stillness to it. We often imagine time as something rushing past us, dragging us forward whether we're ready or not. But if every moment already exists, if the past, present and future are all part of one timeless whole, then maybe there's no need to rush. Maybe it's enough to be the quiet witness, to see a single piece of it clearly while knowing that the rest is still there, waiting. Even in physics there's something like this idea. The equations don't demand a flow of time, they only describe the relationships between things, as if the universe is already complete and we're just tracing its contours. When we measure it, when we think about it, when we live our lives inside it, we're simply revealing what was always there. And if that's true, then maybe time isn't something we're trapped in. Maybe it's something we're watching happen, the way you might sit beside a river and listen to the water move. You don't have to change it, you don't have to hold on to it, you just notice it, and in noticing it, you become part of it. This doesn't give you control over time, it doesn't stop clocks or reverse the past, but it does change the way you see it. You're not a passenger being carried helplessly forward. You're a witness to a universe that has already written its story, a story so vast you can only see it one moment at a time, and perhaps that's enough. Because if the universe is timeless at its core, then every moment you've ever lived is still there, held in that quiet structure. You don't lose it, you only move past it. And in the same way, the future isn't something rushing toward you. It's already there, waiting for you to arrive. The question now is what happens to time in the places where it moves the slowest, where even the ticking of the cosmic clock almost disappears. Because if we can understand those places, we might see more clearly what it means to be the witness rather than the traveller. If every moment already exists, then the future isn't a blank page waiting to be written. It's already there, part of the same timeless structure that holds your past and your present. You can't see it yet, but in a way, you can almost feel it. Little hints, subtle impressions. What if those quiet feelings are echoes of tomorrow? This isn't about predicting the future in any mystical sense. It's about recognizing that if time is a landscape rather than a flowing river, then the future is as real as the ground beneath your feet. You just haven't walked there yet. Sometimes, though, it feels as if we catch a faint reflection of it anyway. A sudden sense of familiarity in a place you've never been. A decision that feels inevitable the moment you make it. These may not be glimpses of the future, but they might be what it feels like to live inside a universe where tomorrow is already woven into the fabric of reality. Physics doesn't forbid this idea. In fact, some interpretations of quantum mechanics suggest that the present may be influenced not only by the past, but also by the future. This is known as retrocausality, a controversial but fascinating notion that what happens tomorrow might leave subtle traces on today, not because time runs backward, but because, at the deepest level, the universe doesn't run at all. Every moment is part of one interconnected whole. If that's true, then what we call the flow of time is only our limited way of experiencing it. We move through the structure one step at a time, and in doing so we mistake our narrow perspective for the whole picture. But sometimes, maybe in dreams, in sudden insights, or in the quiet spaces of our thoughts, we hear faint reverberations of what's already out there, waiting for us to arrive. Even if these echoes are only imagination, the underlying truth remains. The future is not an empty space. It's already there, layered into the universe like the rest of time. And if it's already there, then nothing we will ever do is truly lost. Every word you'll speak, every step you'll take, every moment you've yet to live, they're part of the same timeless pattern, resting in a place you haven't reached yet. There's a strange peace in that. You don't have to fight for every second as if it might vanish forever. It won't. In the block universe, nothing vanishes. You only move through it. But this leads to a deeper question. If the future is already there, does that mean we're only following a path that's been set for us? Or is it possible that what we call choice is part of the structure too? That the freedom you feel is one of the ways the universe expresses itself? That question doesn't have a simple answer. But perhaps it doesn't need one. Because whether tomorrow is fixed or flexible is already part of the same vast whole. And if time is not fundamental, then the echo of tomorrow is not a warning or a promise. It's simply another reminder that everything, past, present, and future, is already complete. And yet, for all its completeness, time still feels real to us. It still carries weight. It still pushes forward, and we still live inside its rhythm. To understand why, we need to look not at the future, but at the strange way time slows down and stretches in the places where gravity bends reality itself. Because there, at the very edge of physics, we can almost see the quiet truth of a universe that doesn't need time at all. The universe is still expanding, but it's not just stretching like a piece of fabric being pulled at the edges. With every moment of that expansion, it's transforming. Galaxies drift apart. Stars are born, live, and burn out. Matter rearranges itself into new forms, and within all of this, time itself, at least the way we experience it, keeps unfolding. At first, expansion might seem simple, a steady widening of space. But the more we study it, the clearer it becomes that expansion isn't only about size, it's about change. In the earliest moments, the universe was almost uniform, a smooth, glowing sea of energy and particles. Now it's rich with complexity. Galaxies spun into spirals, stars scattered across unimaginable distances, planets with oceans and weather and life. Expansion doesn't just spread things out, it turns simplicity into structure, and in that transformation, time seems to take on a role of its own. As the universe grows, it gives rise to new possibilities. Entirely new states of matter appear, new kinds of stars form. Even the way time flows is subtly reshaped by gravity and motion in this ever-changing landscape. If the universe were frozen, timeless and unmoving, none of this would be possible. But because it transforms, it creates a kind of stage where time becomes visible, where we can measure before and after, even if, at the deepest level, both are part of the same eternal whole. This is why some physicists think expansion isn't just something happening in time. It may be what creates the conditions for time to emerge in the first place. Without the universe changing, there would be nothing to measure, no way to tell one moment from another. But as the cosmos grows and transforms, it gives us a reference point, a difference between what was and what is. Time, as we feel it, may be nothing more than that difference written into our experience, and yet, the more the universe expands, the more it also reminds us that what we call time might not be fundamental. Because while stars come and go, while galaxies scatter farther and farther apart, the larger structure of the universe, the totality of everything, may remain timeless, already containing every stage of its transformation. Expansion may simply be the way we walk through it, one frame at a time, while the whole already exists outside of what we can see. If that's true, then even cosmic expansion isn't really about change in the deepest sense. It's about revelation. The universe isn't becoming something new. It's showing us what was always there, hidden until we were far enough along to see it. And if time only appears because of transformation, then what we call the flow of time is really the slow unveiling of a universe that doesn't move at all. But if expansion is a kind of transformation that gives rise to time, then what happens in the far future, when expansion continues and the universe stretches to such extremes that stars burn out and galaxies drift into darkness? Will time lose its meaning again? That question takes us further, to the strange thought that time itself might have boundaries, not in the sense of an ending, but in the sense of fading away, just as it may have emerged in the beginning. And if time can fade, then maybe the universe itself is leading us back toward the timelessness it came from. If the universe is timeless at its core, then everything that has ever happened or will happen already exists, resting quietly in that vast structure. But what if the universe isn't only static? What if, in some way, it is also alive with possibility, like a dream that holds every image at once but reveals them one by one? In a dream, there is no strict clock. You can leap from one moment to the next without any clear transition. Entire lifetimes can seem to pass in the space of a few minutes, and yet you accept it as natural while you're inside it. Maybe the universe is something like that, not because it is literally dreaming, but because, in its deepest form, it doesn't need to march forward step by step. It doesn't need a clock to know itself. When you look at the stars, you're seeing light that has travelled for millions or even billions of years. That light carries information about moments long past, but those moments are not gone. They are still written into the fabric of the universe, and if every moment exists, if every point in time is simply another part of that whole, then the universe is less like a machine running forward and more like a dream where everything is already there, waiting for us to encounter it. Quantum physics even gives us a glimpse of this. A particle can exist in multiple states until we look at it, and then it appears to choose one. In a way, it's as if the universe contains all possibilities simultaneously, and our experience moves through them the way a dream drifts from scene to scene. Nothing is created or destroyed, it's only revealed. And if that's true, then maybe our lives are part of the universe's dream. Every thought you have, every memory you hold, every quiet second you live through isn't separate from the cosmos. It's one of the ways the universe expresses itself. We're not watching from the outside, we're inside it, woven into the same structure that contains galaxies, stars, and the silent spaces between them. If this sounds abstract, there's a simple way to think of it. When you dream, the dream doesn't exist somewhere else, it exists in you. In the same way, if the universe is timeless, then every moment we live is not passing away into nothingness. It's part of a larger whole that doesn't vanish or run out. What we call time is only how we move through it, the way a dream slowly unfolds for the one who's dreaming it. And if the universe dreams, then it dreams endlessly. Every star that forms, every world that spins, every mind that looks up and wonders about it all, they are not separate threads. They are pieces of the same vision, connected across the fabric of reality. We only see one moment at a time, but the dream holds all of them together, and maybe that's the quiet truth hidden underneath all our clocks and calendars. Time is how we live the dream, not how the dream is made. If the universe is timeless, then every moment you've ever lived is still there. Every beginning is still happening, every ending is still unfolding, and if all of it is held together in a single unchanging whole, then maybe there is no true ending at all. Only a kind of endless dawn. Light spreading over a horizon that never fully arrives, because it doesn't need to. When you wake up to a new day, you think of it as something that has just begun. But in a universe where time is not fundamental, that morning has always been there, just waiting for you to reach it. Every sunrise you've ever seen, and everyone you ever will see, is already written into the fabric of reality. You don't create them, you discover them, one by one, as you walk across the landscape of a cosmos that has no single now, only countless moments existing side by side. This is what makes the thought of timelessness less frightening and more beautiful. If nothing is ever erased, then nothing is ever truly lost. The laughter of your childhood, the quiet evenings you thought were gone, the moments that felt too small to matter, they all still exist, held in the same structure that carries the stars and galaxies. The universe doesn't discard anything, it keeps it all. And that means the future is there too. Every hope you carry, every path you haven't taken yet, every unknown moment waiting to unfold, they're already part of this endless dawn. You don't have to rush to reach them. You don't have to hold on to time as if it might slip through your hands. Time isn't something you can lose, because in the deepest sense it isn't something that passes. It's something that simply is. When you look at it this way, even the ticking of the clock feels softer. The urgency fades. You're not racing against time, you're simply moving through a universe that is already complete, exploring it one moment at a time, the way light slowly spreads across a landscape that has always been there. And if that's true, then maybe there's nothing to solve about time at all. You don't have to understand its deepest mysteries to live in it. You don't have to untangle every theory to feel its quiet truth. All you have to do is be here in this single moment, which was always waiting for you and will always be yours. Because in a universe without time, every moment is the first moment. Every instant is an endless dawn. And maybe that's the most comforting thought of all. And as you sit with that thought, let it be enough. You don't have to reach for the future, and you don't have to hold on to the past. You're already exactly where you're meant to be, resting in a universe that has never been in a hurry, that has carried you here, moment by moment, without ever truly moving at all. If this quiet journey has been comforting, if it's helped you drift a little deeper into that timeless space, you're welcome to stay. There are so many more places we can wander together, more questions to ask, more mysteries to soften into, more ways to simply rest in the vastness of it all. And if you'd like to hear those journeys when they arrive, you can always subscribe or leave a small note in the comments to let me know where in this wide world you're listening from. I read them all, and every time I do, it feels like finding another light in the dark. For now, though, let the clocks fade away. Let the universe be quiet around you. Let yourself drift into the kind of calm where there's no before and no after, only this one endless moment. Good night, and welcome, always, to the endless dawn.